How do we solve an absolute value equation? An absolute value is defined as the distance from 0. The value must be positive. Number 1. We are given the absolute value of some number x equals an absolute value of 10. To solve an absolute value, the absolute value must be by itself. Then you copy the number that's inside the absolute value and you copy the number outside twice. So you write this equation twice. But what you do is you stick a negative on the left side of one of the equation. Now, you need to solve for x in both problems. Since the first one is already solved, we know one answer for the problem is 10. However, the other problem is not solved for x. Therefore, we divide both sides by the number in front of x and cross the numbers out, and x equals 10 divided by -1, which is -10. And there we have our second solution. In our next example, number 7, we have the absolute value of some number 6x minus 5 take away 7 must equal -1. We have to get the absolute value bars by themselves. So we need to move this -7 to the right side across this imaginary line. To move -7, we add 7 on both sides. And we end up with the absolute value of 6x take away 5. The -7 and the +7 cancels. We bring down the equal sign, and you're in debt $1, but you paid $7, so you overpaid by $6. Now what we have to do is copy the number inside of the absolute value twice, because we know that there should be two numbers that will produce an absolute value of 6. We write 6x minus 5 equals 6 one time. Then we write 6x minus 5 equals 6 another time. And we stick a negative on the left side of one of the equation. Be sure to use parentheses when there's more than one number on the left side. Okay, so let me recopy everything quickly. 6x minus 5, absolute, minus 7 equals negative 1. Add 7, add 7. We have absolute value 6x minus 5 equals 6. We copied 6x minus 5 equals 6 two times. 6x minus 5 equals 6 two times. And we put a negative in the front of 1. Okay, now we need to solve for x. Now solve for x in the first equation. We need to get x by itself. Draw your line, and anytime you move anything over the equal, you just simply switch the signs. We add 5 on both sides, and we have 6x equals 11, and then we divide by 6, and x equals 11 over 6. Okay, now for the second equation, we must distribute the negative and then get x by itself. When we distribute a negative, all a negative will do is switch the signs. So the positive 6x will turn negative, and the negative 5 will turn positive, and we still have equals 6. Now, we start moving the numbers across the equal sign by doing the opposite. We subtract 5, and we end up with $6 minus $5 is $1. Then we divide by negative 6. And our final solution is x equals negative 1 over 6. And that should be a curly brace. In the second objective, we now need to solve an absolute value inequality. We solve an absolute inequality exactly the same way as an absolute value equation. Number 9. The absolute value of x greater than 1. We copy the problem 2 times. Keep in mind that we only copy the numbers inside the absolute value and the number outside the absolute value twice. And then we stick a negative in front of the left side on one of the inequality. Doesn't matter, just pick one. Then what we do is we solve for x. X in the first equation is already by itself. We know that x greater than 1 is going to be all the numbers to the right of 1. But it does not include 1, so we draw an open circle. In the other problem, x is not by itself, so we need to get x by itself. So we divide by negative 1. But when we divide or multiply by a negative 1, we have to remember to flip the inequality. If you forget to flip the inequality, it produces the wrong answer. Therefore, x must be less than negative 1. Now we need to graph the solution for the other x. X is less than -1. That means we color everything to the left of -1, but we don't color -1. The final answer is x is greater than 1, or you can use a U symbol instead of the word or. X is less than -1. Number 11 is now a less than. The absolute value of 3 times x plus 1 plus 9, close absolute value, is less than or equals to the number 12. A less than problem is solved no different from a greater than problem. You still copy the numbers inside and the number outside twice. And you have to remember to stick a negative on the left side of one of the problems. Since there's several numbers, make sure you put a parentheses and then stick a negative outside. To solve, we need to simplify using please excuse my dear Aunt Sally. We take 3, multiply that to x, and take 3 and multiply that to 1. Therefore, we have 3x plus 3 plus 9 is less than or equals to 12. We solve for x by simplifying 3 and 9 to get 12. We then move the 12 over to the other side, and we divide by 3. 12 minus 12 is 0, and when we divide by 3, we get our very first x. Okay, now graph. And we need to color all the x's to the left. And we also color 0 because 0 is equals to x. Okay, for the other problem, we need to follow please excuse my dear Aunt Sally and work inside of the brackets before we handle the brackets itself. We multiply the 3 to the x and the 3 to the 1. We have 3x plus 3 plus 9. And all of this still is inside of a brackets, and there's still a negative outside. We bring down our less than or equals to 12, and then we distribute the negative to all 3 numbers inside. You can also combine the 3 and the 9 together before doing this, but we recommend you immediately distribute the negative and drop the brackets. Negative times positive is a negative 3x. Negative times a positive is a negative 3. A negative times a positive is a negative. We can drop the brackets now and drop down the less than or equals to 12. We then combine the like terms together and get negative 3x minus 12 is less than or equals to 12. And then we proceed to get the x by itself by adding the 12 on both sides. And we come out with negative 3x is less than or equals to 24. And we have to remember that when we divide by a negative number, we need to switch the sign. So immediately erase and flip. And therefore, our second x must be greater than or equals to negative 8.